Gravitational force. Learning goals. Describe gravitational force. Observe the effects of gravitational force on objects. Infer how gravity affects movements of objects and people. Devise ways on how to overcome the effects of gravity in performing tasks in daily activities. You know that all objects that are thrown upward fall. Gravity causes the object to fall toward the earth. Think about what happens when you drop two objects with different weights. Does one fall faster than the other? What if these two objects are dropped on the moon? Will it have a difference? Gravitational force. On Earth, what goes up comes down. All objects are attracted toward the center of the Earth due to gravity. Gravity was observed by Isaac Newton. He recognized that an apple fell straight down because Earth attracted it. He wondered whether this force might extend beyond the trees to the clouds, to the moon, and even beyond. He hypothesized that the force on the apple must be proportional to its mass. Gravitational force is the force of attraction between all masses in the universe, especially the attraction of Earth's mass for bodies near its surface. The more distant the body from the Earth, the less the gravitational force of attraction is. Would air and mass affect falling objects? When you drop a plastic ball and a metal ball from the same height at the same time, the balls fall to the ground. The force that acts on the objects is gravitational force. You observe that there is a difference in the falling speed between the two balls. The ball with the greater mass falls at a greater speed, while the ball with the lesser mass falls with the lesser speed. You concluded that heavy objects fall faster than lighter ones. Try to drop two pieces of paper of the same kind and mass. One is crumpled and the other one is uncrumpled. Will it give the same result? You will observe that even the pieces of paper have the same mass. The crumpled paper will land on the ground first. It is important to realize that objects falling on Earth must pass through air. When you drop the crumpled paper and the plain sheet of paper at the same height, you will notice that the crumpled one lands on the ground first. Air resistance acts against the motion of the plain sheet of paper more than it does against the crumpled paper. As the result, the air slows the plain sheet of paper more than it does with the crumpled paper. The speed of falling objects will be different on Earth and on the moon. If the air is removed, the air resistance will disappear. When the hammer and feather is dropped on Earth at the same time, the hammer will fall faster than the feather. Air resistance acts against the feather, which slows down its falling. But if you drop the feather and the hammer at the same time on the moon, the hammer and the feather will fall at the same speed. The moon has no air, therefore, there is no resistance acting on the falling object. Scientists have learned that when the effects of air resistance are removed, objects of different weights fall at the same speed. Figure 6.25 shows the hammer and the feather fall at the same speed when dropped on the moon due to the absence of air resistance. In addition, air resistance may be too small to matter for objects that are fairly compact. Over short distances, such objects fall at the same speed. When you throw an object upward, you apply force. What you throw up goes down because there is a force that pulls the object to the ground. Figure 6.26 shows a ball which is thrown upward falls due to gravity. Gravitational force pulls down anything toward the center of the earth. Objects fall toward the ground because of gravitational pull. The direction and the amount of force can be measured by a spring scale. A spring scale measures the force of gravity exerted on an object. The amount of force needed to move an object depends on the mass of an object. The spring scale attached to an object measures how much force you need to use to lift the object. The force of gravity exerted on an object is called the weight of an object. Weight is measured in newtons. The spring scale shows that the direction of gravity is downward. It also shows that weight is the downward force of gravity on an object. Key concepts. Gravitational force is the force of attraction between all masses in the universe, especially the attraction of Earth's mass for bodies near its surface. Gravitational force is affected by distance. The more distant the body from Earth, the less the gravitational attraction is. When objects are closer together, the gravitational force is greater, but as the distance increases, the gravitational force decreases.